All right, here we are in section 12.3 on logarithmic functions. Now our objectives are introducing the common logarithmic function, finding the inverse of the common logarithmic function, and working with logarithms that have other bases. So what is a common logarithmic function? So a common logarithmic function is an exponent having a base of 10. This is either denoted just plain old log or log base 10. Both of these are the same thing. If they don't put a base here, it's assumed to be 10. Now, if the common log of a positive number x is denoted log x, it's calculated as follows. So if x is written as x equals 10 to the k, then log of x equals k, where k is a real number. So that is the log of 10 to the k power is equal to k, and the function is given by f of x equals log of x, and that's called the natural log. So some things to think about here. So really what this is saying is here we have log base 10 of x equals k. And what we're going to do is we're going to take the base, raise it to the power of k, and then set it equal to that. So it's going to be 10 to the k equals x. So that's how we go from here to here. And then to go from here to here, we can go backwards. We just have to put the pieces in the proper place. So this is the base. This is going to be what it's equal to, the y basically. And then this is going to be what we're taking the log of. So that's kind of how we can go from either a log form or the exponential form or the log or the exponent form. So we can go back and forth between those two because sometimes it's easier to work in this form. Sometimes we can work in this form. Now, another thing is what it's saying here. So when we have a log of say 10 to the k, what we can do is if we have this base, when we have log, and it's again nothing here, it's the same as log 10. So if we have log 10 of 10 or 2 of 2, or if these two things are the same, what we can do is we can bring that k down in front, and then if this is the same, the log 10 base 10 or log e base e or whatever, if those are the same, that's the same thing as 1. And so then we just have k, and hence this piece here. So all they're doing is they're bringing down the k out in front, and then they just have log base 10 of 10, and that's just 1. So we just have k times 1, which is k. So those are kind of to explain how they're getting these. All right, so here we're supposed to evaluate each expression if possible, log of negative 1,000 and log of 100 squared. All right, well, we haven't talked too much about this, but part of the rules was we have to take a positive number here. And so because it's not a positive number, then the log is undefined. Okay, so that's the key piece. So over here, we had to say it's a positive number x. Well, like I said, that's not a positive number. Now this one, remember, here, what we can do is we can think about this in two ways. We can first, it's positive. We can first square it, and then we get that value. And then we have to write this value as some 10 to some k power. Okay, well, that's going to be 10 to the fourth because there's four zeros. And then we can use the log property. And remember, if we have the log of 10 to the fourth, we bring that 4 down in front and we get 4. Okay, so that's what they're doing here. Another way to do it is, what is 10? Well, 10 is 10 squared, and that's squared. And so we multiply that. So that's 10 to the fourth. So we can get that right away, and then we can take the log of that, and then it comes down and does the same thing. Or we can do like they show, square the 100, get the 10,000, and then go and get the 10 to the fourth. So there's two ways to do this at least when you're doing these. Now we're supposed to simplify each common log. All right, so again, we have 10 to what? 10 to the third, so that's just going to be 3 on that one. And so that would be how it is because we're going to take log 1,000, which is equal to 10 to the third, so we bring down the 3 out in front. And really, they should be showing a log of 10 to the third, so that way when you bring that down here, the log base 10 of 10 is 1, and then we just have 3. Now here we have this. Well, we can rewrite that as 10 to the negative 2, right? And so what we can do is what they show here, 10 to the negative 2. Then log of 10 to the negative 2, bring that negative 2 down, and we have negative 2. And finally, log of 55, that's not one that's base 10. So what we do is we plug that one into the calculator. And so log 55 is going to be 1.74036 and so on. And so again, depending on where they tell you to put the decimal form. If they say to two decimals, it's 1.74. But then, if they say 4, then we'd have to round that to a 4 like they show here, and then we can go backwards and say 10 to that power is at 55. Well, yeah, close enough. If we would have used the whole thing, it would have been in 55 exactly. All right, so let's stop there and we'll come back for some more.